Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to YouTube channel Chandan Physics. In this video, we are going to discuss computer memory, memory organization and addressing, memory interfacing, memory map. Let's begin. Computer memory. A computer system needs a store for the processing of the versatile assignments that are imposed on the computer by the users. Therefore, a store is required to keep bulk of programs and data. These are processed by the programs for further computation. Therefore, the store for saving the information is known as memory. The store where the information are stored is known as memory. How memory is organized? Memory organization and addressing. When we are dealing with living organisms, so the basic building blocks of a living organization or living organism is cell. In that way, when we are dealing with computer memory, so the fundamental building block of that computer memory is memory cell. Then combination of memory cell is known as register. The interconnection of single memory cell is known as register. Then the combination of registers, finally we have our computer memory. So when a group of registers are interconnected to form a memory. First memory cell, then register, and finally we have the memory. Let we understand how the organizations are in computer memory. First we understand memory cell, which one is the building block of computer memory. So it is an electronic circuit to store one bit of binary information. It is a basic unit for storing single bit information, and these cells are called binary cells. In circuit diagram we show it. Two AND gates, interconnected with each other. A NOT gate is used. Provide input by taking that line. Then RS flip flop is used. R S output as 0 stands for reset. For set it will be 1. So 1, that is input towards another AND gate, another line, here the combination line of these two AND gates is used for write, that line is used for read. Finally, we have the output line. This section is a memory cell. That of memory cell is set to store a logic 1, set to store a logic 1 and reset to store a logic 0. And logic 1 refers to high voltage level, when logic 0 refers to low voltage level. So, in case of semiconductor memories are usually made from that kind of flip flops, and these are designed using transistors and charge storing circuits containing capacitors. We can show that memory cell by taking its block diagram. Its block diagram as this is the memory cell. Here is the input data line. Input data line. That for write line. Output data line. Read line. Memory cell, which one is the fundamental building block of computer memory. Next, register. Register, the interconnection of single memory cell is called register. So, how register is organized? Let me take an example of 3-bit register. For 3-bit register, you have to take in 3 binary cell. One binary cell, 2 binary cell and 3 binary cell. Binary cell. Binary cell, that is a memory cell. Binary cell. The interconnections that is for write line. The read line. It has input and output line. input line, here is the output line, then it will be input line, output line, input line, output line, binary data, let 1 1 0 is used. In that way a register is organized. In that figure it is a 3-bit register, that is the organization of 3-bit register. In the 3 binary cells are interconnected in such a manner that the write control line of all 3 memory cells are connected together, and the read control lines are also connected together. The bits, which is the bit or we can say the data to be written in each memory cell are given at their input data line. These will be written on application of write signal in the common write line. Further, the content in each cell can be read on application of read signal line. The contents will appear at their output data line at the same time, that is the register stores 3 bits in its 3 cells, 1 1 0, 3 cells, 3 bits are stored. So, the organization of 3-bit register. Next, overall that memory is the interconnection of registers. Now we have to take 3-bit forward, means 3-bit per word memory into consideration. So, how that organization? Take 12 number of binary cells, 3 in each row. Binary cell 1 2 3, binary cell 1 2 3, binary cell next 1 2 3, binary cell taking the input lines. Read the input line, input line, input line, input line, input line, input line. Next input line, input line, input line, input line, here input line, input line, input line, input line. Next, each has the output lines. Here the output lines. Obtain the output lines. Next, the output lines. This is the output line, output line, output line, output line. Again, output lines. Read lines and write lines. Taking the write lines, the write lines, this is write line to this, write line, write line. Here the write line, write line, write line, write line. Next, that is the write line. For read line, 3 read line, read line, read line. Next, read line, next read line, these are the write lines. Write lines, here we write as 0 0 the binary data, 0 1 1 0 1 2 3 4 5 6 7 8 9. Okay, there will be 12 numbers, 12 numbers. Another 3 binary cells are there, 1 2 3, same, one input line, that is the output line, input line, output line, input line, output line. For read line, this is the read line, it is read as a 1 1. Next, for write line, 3 write line, 3 write line. Here are the write lines, write lines. Here are the outputs, these are the output columns. output, output, output. The inputs, and the read lines. Read lines. This is an example of a forward, or we can say 3-bit forward, 3-bit forward memory. 3-bit forward means 12 number of binary cells are required to us. Binary cells, or we can say it as memory cell, which one is the building block of computer memory. In this way we organize the memory. First memory cell, then registers, example of 3-bit register, and finally the computer memory, which is the interconnection of registers. An example as forward or 3-bit word memory. This is the organization of computer memory. Next, memory addressing. Memory addressing, binary code specified to each word in a memory for selecting an appropriate word for either reading or writing is known as address of that given word. We classify the memory addressing into two. One is MAR, another one is MDR. MAR, that is memory address register, is the memory address register. Register at the interconnection of memory cells. On that basis we classify the memory address. MDR, which one is abbreviated as memory data register. Memory data register. In MAR, the address is placed in a register which is known as memory address register, and in abbreviated form MAR. This memory size is related to the size of MAR, that kind of memory size. If we need a 2-bit MAR, memory address register, example, if we choose 2-bit memory address register to address forward memory, and 3-bit MAR to address 8-word memory. Similarly, for addressing n bit mar is used to address 2 to the power n word memory. Next, MDR, memory data register, where data register, that name indicate it is data register. In fact, MDR is a register in which the data to be written in a memory or the data read from a memory are placed. Here data to be written in a memory or the data read from the memory are placed. The data to be written in memory cells is placed in MDR during the write operation. So, it is dealing with 3-bit words. It is dealing with 3-bit words. Therefore, MDR will be a 3-bit register. On that basis of memory addressing, we classify it memory address register or memory data register, that is memory addressing to that particular register. Next, memory interfacing. Interface is the place where two systems, subjects or organizations meet and interact. But in case of computing, it may be a device or program that enabling a user to communicate with computers. It is known as memory interfacing. So, let we take an example of memory interfacing, that memory interfacing with microprocessor. And memory, these are interface by using the data bus, these two are interact by taking address bus. This is an example of memory interfacing, that is the memory interfacing with microprocessor. Next, memory mapping. Memory mapping, that is the tabular representation of organized distribution of memory among different sections of a computer system, is known as memory map. Taking an example, a simple memory map of an IBM PC. In that of case, the memory mapping a 20-bit address of a microprocessor allows 1 MB of memory space with address that ranged from 0000 to FFFF. So the memory locations we consider for ROM, that around 256K, the range that is FFFF H to COOH. For video RAM, (128K), its range BFFFH to A0000H. For RAM, that is 640K, its range FFFFH to 0000H. This is the memory mapping of an IBM PC. So here, with the help of this video lecture, we understand computer memory, organization and addressing of computer memory. First, organization of memory cell, next organization of a register, then organization of a memory, memory addressing and classification of a register on that basis of memory addressing, MAR and MDR. Memory interfacing, example of memory interfacing, memory with microprocessor. Next, memory map, an example to IBM PC. So, with this useful and informative notes, let me wind up this session. Thank you.